Yes, the title of this paper is Software Sentiment Analysis Using Deep Learning Approach with Various Word Embedding Technique. And this work is also funded by Test AI Solution Limited. And this is a joint work with one of my BTech student, Chandra, and myself, and one of my colleague, Lalita, Murthy, and Professor Aneesh Krishna from Curtin University, Perth. So these are the seminar outlines. First, we'll go through the introduction, study design. Then we will discuss what types of framework we are using for the sentiment analysis, then experimental result. Then we are also going to compare and we are going to find the best combination of matrix. And finally, conclusion with some future work. So sentiment analysis, basically we are applying for the software engineering task to find the moods and feeling behind the textual data. So when any software engineers are giving the comments related to the any code, then we are going to find whether the comments are positive comments or whether the comments are negative comments. So before the automation of the process, basically we are using the manually we are going to check all the comments, and then we are going to decide whether this comment is positive or negative. But manually it is a very time consuming process. So why not we will develop one model, and that model will take the software comments as an input, and automatically it will predict whether the comments are positive and negative. And if we are getting some negative comments, then we have to check why we are getting these types of negative comments for these types of code. So here basically our objective is to predict the sentiment of the software comments or sentiment of the software engineering comments based on machine learning algorithm. And here we have also validated our work with 3 different types of framework. So here basically our main objective is to find the best embedding technique for software engineering comments, and also the best feature selection technique, same like sampling technique and machine learning technique for the software engineering comments. But these are the different technical challenges when we are working for the software sentiment analysis. The first one is word embedding technique, because whatever the data we are getting in the terms of text with the values like that, whether this text is positive comments or negative comments. So here when we are going to apply any type of data mining technique or any type of machine learning technique, that will mainly work for the numerical value, that will not work for the text data. So that's why we are using the different types of embedding technique to find the numerical representation of the text data. And there are various types of embedding techniques are there, and they have designed based on the different platforms. Then after that, when we are using the embedding technique like the TF-IDF, term frequency and inverse document frequency, where we are using the each word as a feature, then we are getting the huge number of features. So that's why we are also using the feature selection technique to remove the irrelevant feature and find the best combination of word that will decide whether these comments are positive or negative. Our data set, whatever the data set we have used for validation, most of the cases we are getting the positive comments. Very few we are getting the negative comment. And here the negative comments are very important, since our data is suffering from class imbalance, because we are not getting the equal distribution of sample for both the classes. That's why we are also using the different types of data imbalance technique. So this is the data set we have used to validate our framework. We have used the app review data set, we have used the Jira data set, and we have used the Stack Overflow data set. If we are going to check the Stack Overflow data set, most of the cases we are getting the positive comments and very few we are getting the negative comments. If we are going to check, we are getting approximately 1300 positive comments, and we are getting less than 200 as a negative comment. So this will directly showing that whatever the data set we are using for validation, that is suffering from class imbalance problem, because we are not getting the equal number of sample for positive and negative sentiments. So that's why we have to apply the different types of data imbalance technique or different types of data sampling technique before applying the machine learning algorithm. Then here we have used the first approach, because this is the first technical challenges to find the numerical representation of the text. So we have used a different type of embedding technique. First one is term frequency and inverse document frequency, because this is the most frequently used embedding technique. Here simply we are taking the each word, whatever the words present in the comments, we are taking as a features, and then we are finding what is the frequency of the word and what is the inverse document frequency of this word, and based on that we are going to predict. Then in this case, in the case of term frequency and inverse document frequency, the bigger problem is we can only make the conclusion like that, whether these two words are same or not. But we cannot find the conclusion like that, whether these two words are more similar or not. So that's why we are using the different types of embedding technique. This technique basically one type of, we can say like the one types of dictionary that will give the numeric representation of English word. So that's why we are using the continuous bag of word. We are using the skipgram. We are also using the pre-trained globe model, pre-trained Google News word to vector and fast. So here last three are the already pre-trained model we are using to find what is the numerical representation of this word. But we are also generating our own embedding technique by using the concept of continuous bag of word and skip. But before applying this word embedding technique, we have removed all the stop words, bad symbols, spaces before applying this embedding technique. Then we have used a different type of feature selection technique, because when we are using the embedding technique, we are getting the one vector, and after that we are going to find what are the element of the vectors are important for the sentiment analysis, because not all the positions are important to decide sentiment. So that's why we are using here ANOVA test. Then we are also going for the principal component analysis. And after that, we are using the four different types of feature ranking technique. So first, we are going to rank all the feature. And then after that, we are selecting the top log 2 base in number of features. But mainly our objective is to remove the irrelevant feature and select the best set of relevant features. So that's why first we are using the ANOVA test. Then we are going for the principal component analysis. Basically, our objective is to remove the highly correlated feature and to find the best combination of uncorrelated feature with high variance. Then we are going for the gain ratio, information gain, classifier attribute evaluation, and 1R attribute evaluation. In all the cases, we are going to rank the feature, and after that, we are selecting the top log 2 base in number of feature. So if you are going to find the number of features in the case of gain ratio, information gain, classifier subset evaluation, and 1 are very small as compared to the original set of features. Then again, we are using the similar types of deep learning approach. Here we are taking the 8 different types of deep learning approach by changing the number of hidden layer, by changing the value of dropout layer. And we have validated this all the deep learning by using the 5-fold cross validation approach. So where we have divided the whole data into the 5 equal parts, and at a time we are using the 4 parts for training and 1 part for testing. And we have to continue this process 5 times so that whatever the conclusion or whatever the performance we are getting, that will consider as a general performance. We are not using the train and test split. We are using the 5-fold cross validation. And then after that, we are comparing the performance based on the accuracy, F measure, and area under curve. So this is the overall framework. First, we are taking the software sentiments. We are taking the sentiment in terms of positive and negative, because the sentiments is present in the text format. So we are using the different types of embedding technique to find what is the numerical representation of those sentiments. Then after that, we are applying the 2 different type of data imbalance technique. One is smooth and second is borderline. Then after that, we are getting the original data. Then we are applying the different type of feature selection technique to remove the irrelevant feature and select the best combination of relevant features. So here we are using the ANOVA test, gain ratio, principal component analysis, information gain, 1R, and correlation attribute analysis. After that, we are using the 8 variant of deep learning approach, and then we are comparing the performance using the accuracy, area under curve, F measure. So this is the result of result in terms of precision and recall. And if we are going to check, in most of the cases, we are getting the higher value of precision and recall. But since our data is suffering from class imbalance problem, so here we are making all the conclusion based on the area under curve, not based on the accuracy, based on the area under curve. And from the research, we found that if the area under curve value is greater than 0.7, that will consider as a model that has the capability to predict sentiment, or that has the capability to predict the output based on some unseen input. So here what we are getting like that, in most of the cases we are getting the AUC value 0. Most of the cases we are getting the AUC value greater than 0.7. that will confirms that whatever the models we have developed that have the capability to decide the positive and negative sentiment based on the user comments. So here we have taken the original data, then original data with ANOVA, then a smooth with original data and a smooth with ANOVA. In all the cases, we are getting these types of area under curve. Finally, we are going to suggest which types of embedding technique is best, which types of deep learning approach is best, which types of sampling technique is best, or which types of feature selection technique is best for the software sentiment analysis. So here we are comparing based on the box plot diagram, but most of the cases we are making the conclusion based on the area under curve. And from the area under curve, what we are getting like that Google word to vector. So if we are using the pre-trained model to find the numeric representation of the text, that will give the better result as compared to the TF-IDF, COP, skipgram, globe, and fast text. Even in the case of Google word to vector, we have the less number of feature, but that is giving the better result as compared to the TF-IDF, because in the TF-IDF we are using each unique word as a feature, so we are getting the huge number of feature. In this case, we are getting approximately 30,000 feature. But when we are using the Google word to vector, we are getting approximately 468 feature. Same like that, after that, we have also applied the hypothesis testing like that fragment test. And in all the cases, we are getting the p-value less than 0.05. That will confirms that the models, the prediction or the performance of the model totally depend upon the embedding technique. So if we are changing the embedding technique, definitely the performance of the model will significantly change. If we are going to find which one is the best technique, then in this case, Google word to vector, because we are making the conclusion based on the area under curve. And here we are getting the minimum rank or mean rank 1.37. That will represent like that. If we are using the Google word to vector as an embedding technique, that will give the better result, or that will give the significantly better result as compared to other embedding techniques. Then after that, we are using the same like that original data ANOVA gain ratio information gain. And in this case, what we are getting like that ANOVA is giving the similar types of result as compared to the original data. With the least number of features, it will give the similar result as compared to the original data. But when we are going for the cost benefit analysis, then in this case, maybe we can recommend the gain ratio information gain and 1R, because in this case, we are taking very small number of features, because we are only taking log 2 base in number of. If original feature is 1000, we are only taking the 10 feature to develop the model. And with the 10 feature, we are getting the almost, if we are going to check in the case of original data, we are getting 0.9 as a median, but in the case of information gain, we are also getting 0.75 as a median area under curve. Then again, we have applied the fragment test, fragment mean rank test, and in all the cases, we are getting the p-value less than 0.05. Means definitely it is showing like that the performance of the model will also depend upon the different types of feature selection technique. If we are changing the feature, definitely the performance will change. And if we are going to suggest, then we will suggest to apply the ANOVA test, because in this case, we are getting the significantly better result as compared to original data with less number of features. With the less number of words, we can say like with the less number of words, we are getting significantly better result as compared to the original data. Same like that, if we are going to compare the different types of feature selection technique, because it is taking the least number of features, we are only taking the log 2 base in number of features, but that is also giving the little bit good result, we can say, if we are going for the cost benefit analysis, because it will also take the least time to predict the sentiment of the user. Then we are using the three different type of sampling technique. One is original data smooth and borderline smooth. And in this case, we are getting the smooth is giving the better result as compared to the original data and borderline smooth. So again, we have applied the fragment mean rank test, and here we are also getting the value p-value less than 0.05. That will confirms that whatever the models developed on the balanced data using the smooth have the better ability of prediction as compared to the original data and borderline. Because in this case, we are getting 1.73 area under curve for the smooth and 1.98. That is also giving the similar result, but that is giving the better than the original data. Finally, we have applied the different types of deep learning approach by changing the number of hidden layer, by changing the value of dropout layers. And in this case, what we are getting like that, if we are going to increase the number of hidden layer, the performance will not increase. Because normally what we are getting like that, so if we are going to increase the number of hidden layer, basically the performance will increase. But in our case, the performance is not going to increase. So if we are going to check only for deep learning 2, the performance is a little bit increased, but after that we are getting the constantly the similar types of performance. But when we are going for DL6, 7, and 8, we are getting the lower edge compared to DL2, 3, 4, and 5. So here we are also getting one conclusion like that. So while increasing the number of hidden layer, the performance will not increase. If we are going to find which one is the better one, then deep learning 4 is the best one as based on the fragment rank test. But when we are changing the number of hidden layer, definitely the performance of the model will significantly change. So these are some final conclusions. The first one, the high value of area under curve, because in most of the cases we got the value greater than 0.7, confirms that whatever the models we have trained that have the ability to predict the sentiment of the user based on the user comments. If we are using the sampling technique like that, smooth and borderline smooth, means before the training, if we are using the sampling technique like smooth and borderline smooth to balance the data, that will definitely give the better model as compared to the original data. If we are using some feature selection technique like ANOVA before applying or before taking as an input, then it will give the better result as compared to the original data. Same like that, if we are using the deep learning model with one dropout layer with the 2 hidden layer, that will achieve the better result as compared to other techniques. So we cannot say like that if we are increasing the number of hidden layer, the performance of the model will improve. Then after that, the final conclusion, if we are using the class imbalance technique that we have already mentioned, if we are using the smooth or borderline smooth, definitely that will give the better ability of prediction as compared to the original. So these are some outlines, these are some references for this paper. If you have any question, then please ask.
Thank you very much. Nice presentation. Do we have any questions from anyone? No, don't see any. Thank you very much, Dr. Kumar. A very nice presentation.
Yeah, thank you. Yeah,
thank you.